morning everyone. My name is Bhaumik and this is my ELP project. I have made the project on the phone adapter. So here is the phone adapter. So this is what the phone adapter looks like, and this is the all the components used in the phone adapter, and this is the actual circuit of the phone adapter. So this is a circuit diagram of the phone adapter. There are usually three components to it. First is the step down transformer, uh, which steps down the voltage coming to our home. Second is the full wave rectifier, which converts the AC to DC, and then soothing and regulation, which tunes that DC voltage. We will see that it in detail in the further coming slides. Step down transformer. It steps down the in incoming input to 20 volts AC voltages to our house to 9 volts for operation of the rectifier. This is the circuit diagram of an transformer. The number of coils are less on the secondary side. Thus, in this case, thus it steps down the voltage. Here comes the full wave rectifier. So rectification is the process which converts AC voltage to DC. But the voltage conversion will not be 100%. The full wave rectification rectifies the negative component of the input voltage to the positive voltage and then converts into DC pulse current utilizing a diode bridge configuration. Here we can see in this diagram how the input AC voltage goes through these four diodes, which will two will be on at a given time and two will be off at a given time, and we will get a output signal over here, something like this, which in which the negative input voltage has been eliminated. But we need to keep in mind that this waveform is further soothed by charging and discharging of a capacitor, resulting in a clean DC signal. There will be an incompleteness in conversion, which will always happen, as there is a practical remnant that will be cleared in the upcoming slides. Smoothing and regulating. The incoming DC voltage from the rectifier needs to be smoothed and regulated for further use. Here, where we'll see what happens in smoothing and regulating. First, smoothing or filtering. The converted DC voltage has some ripples in it, which means it has some AC properties which will be filtered by capacitor filter circuits. The output of this process will be almost as expected. So here we can see in this pictorial representation the incoming DC voltage from the regulator has some ripples in it, which thus induces some AC properties in it. Uh, to get a perfect DC supply voltage, we pass it through a filter circuit, which is basically a parallel RC combination with a very large time constant. And the output is a, a signal which has output signal is a voltage which has very less ripples and thus is almost acts like a DC supply. This voltage needs to be further regulated to maximize its use. So, regulator. After achieving DC without ripples, that 9-volt value have to be cut down to 5 volt. To do this, voltage regulator comes to the place. It gives a constant 5 volt supply as an output for 9 volt input. Finally comes the load or the smartphone. This is the beneficiary of the total process. 5-volt output is consumed by that charger in order to carry electrons inside the smartphone for filling up the battery energy. Development. Earlier in 1880s and 1890s, nickel cadmium battery chargers were used. And then came the time of portable power bank. Uh, the smartphones were found guilty of gobbling up power due to dependency on using it to help us in our daily task. In an attempt to remedy the issue, the portable power bank was introduced. And then finally was the wireless charger. The electrical pioneer Nikola Tesla had demonstrated that wireless charging was possible. However, the technology doesn't match practical application until recently. One of the biggest players in the smartphone industry, Apple, has just launched the MagSafe charger compatible with other devices that use QI charging. Thank you.